In this lecture we're going to have a look at circular motion, and we're going to use the example of a hammer thrower to demonstrate the forces that are involved. So here we have our hammer thrower, and we're going to say that the hammer he is throwing has a velocity. Now remember, velocity is a vector quantity, so it has both size and a direction. So we'll say it has a velocity of 2 meters per second in that direction. You can see that he's holding onto the chain in the middle, so you know by instinct, a hammer thrower, that hammer isn't just going to fly off and shoot away in this direction. It's going to follow a circular path. So we're going to make him rotate, and you'll see what's happening to the direction that that hammer is travelling at all stages, and we'll use that to get to our first definition. So now he's rotating, you can see that the hammer is constantly changing direction. So if its direction is changing, the velocity's direction, that means the velocity itself is constantly changing. And remember, another key definition, a constantly changing velocity is an acceleration. So here we have an object that is constantly accelerating. Now we mentioned previously Newton's first law, which says to accelerate, there must be a resultant force acting on the object. But it's moving at a constant speed, it's just its direction that's changing. So what force can we see that is acting on that object? Well, the only one that's obvious and apparent is the force of the chain on the hammer as he's holding onto it as he's rotating around. And that is the force that we require. So now we've added that force on, you can see it is constantly at 90 degrees to the velocity, and is always pointing towards the centre of the circular path. And we actually call this the centripetal force. Now, whenever you have a curved path or circular motion, there is always this centripetal force. One way you can remember it, the word is actually in two parts. Centri means centre, and petal means seeking. So there we have our centre-seeking force. Other examples of centripetal force are gravity. So the force that keeps the Earth from to orbit the Sun always acts towards the Sun, which is the centre of the orbit. So for circular motion, there is always a centripetal force.